Good morning, one and all. This is Dr. Dinah here, and welcome to our session on data mining. So, we've been looking at data mining, and we've started with Unit 1, and we have looked into what data is, how data can be transformed into information, and how information is then used to produce knowledge. And knowledge is represented in the form of patterns. And we saw data mining as the process that transforms information into knowledge. So, with this idea, we started with the methodology called knowledge discovery in databases. So, we've looked at a process that can help us mine that knowledge out of simple databases. And we've also seen that it is necessary to have clean data for the mining process. Unless the data that is given as input is clean, the output will not be effective. So, in order to get an effective output, the first process that we do is called as data cleaning. And when we looked into data cleaning, we have realized that the real world data is dirty, and we have also seen what are the dirts available in the real world data. So we have seen that data can be incomplete, it can be noisy, or it can be inconsistent, or it can also be intentionally given as wrong information. So there are different levels of dirt in the data. And we have started looking into incomplete data, or it is also called as missing data. We have seen what are the different ways in which incompleteness is caused in data. So it may be due to an equipment malfunction, or it can be because of inconsistency with other records and some of them got deleted, and data might not be entered due to misunderstanding, and certain data may not be considered as important at the time of entry, but later you realized that that data is required, so you added another column, and for all the data students or the tuples that existed earlier, that column was empty. So that's how data becomes missing. And we also forget to register the history once you start updating a particular value. And there are cases in which data may need to be inferred from another data which is given in another column. So all these aspects are looked into, and then these are the sources of incompleteness of data. From this source, once we have identified the source, now it is our responsibility to correct that missing value. One methodology of correcting the missing value is to ignore the tuple completely, and then you can use some other manual methods for filling up of missing values, but that is very, very difficult. It's a very tedious process, so we will have to avoid filling in the missing values manually. So the next option that we have is to automatically fill. What do we fill it with? We have seen some of the methods that can be used to fill missing values. One is replacing with a global constant, or you can take the mean of the attribute, or you can group the tuples into certain SAMP grouping called as class, and then for every particular class you can take the attribute mean. This makes so much sense. Or you can use the most probable value for that particular missing data. This we can use Bayesian formula or decision trees for computing of the most probable value. And we have also seen that noise is an error in data. So what are the ways in which noise is introduced in the system? Because of faulty instruments, data entry problems, or it can be data transmission problem, or it can be because of technology limitation, or it can even be because of the inconsistency in naming of different databases, for which we saw an example of how the name of the student is written as different ways in different databases. It could be name, it could be name of the student, or it can be the first name, full name. All of these are different ways in which this name of the student is entered in the database. So because of the naming convention also, we might get some error in data. And we have seen that apart from these, you can also come up with incompleteness in the data records or duplication of records and inconsistency when you try to merge between multiple databases. So when we encounter some of these noises in data, how do we handle them? How can we correct this noise in data? The first methodology we saw was binning. Binning is a procedure where we sort out the data and then you divide them into groups. You look at the behavior of a particular group and understand whether there is an error in data or not. An example could be, now all the students of a particular department of a particular year might have been uh, might have addressed some examination, and that examination seems to have got an overall of 60% for most of them. And when you try to identify if there is a noise in that data, you can group them department wise, you can group them section wise, or even year wise, and then find out if all of them are having the similar behavioral pattern. According to the pattern, we will be able to identify if there is any error in the data. And when you find an error, you can use the mean of the mean value of all the entries in that particular bin to smooth out your noisy data. So if the noise says on an average everybody has got only 60, but that noisy value alone has got 85. So in that case, you take the mean value of that particular bin for that particular column, and then somewhere close to that you can smooth your error or the noisy data. And then you can go in for regression. Regression is a line fitting. So I have told you that regression always means line fitting. Line fitting means I have one independent variable and one dependent variable. So based on the value of the independent variable, the dependent variable is going to change. Just like how we have seen the basic line equation, y equal to mx plus b. So x here represents the independent variable and y represents the dependent variable. And based on the value of x, the value of y is going to change. Now, if I know the value of x, I can anytime find out the value of y. So, if you can plot that particular column, say for example, the age and the salary are the two variables. There is a dependency between age and salary. So if I say that as age increases, the salary also increases. So I can represent the salary in terms of age. And if, for example, I find that the salary value of one particular person has been entered wrongly in the database, and if I see that it is a noise, then based on the regression line that I have created using age and salary, I can find out what will be the salary of that noisy error data given that particular age. Say for example, my data and one of my friend's data is entered. My friend's data, there is a error in the error in the salary value. So I can look up into his age, find out what would be his most probable salary, and replace that erroneous value. That's how regression works. Or you can even go in for clustering. Clustering is where you group the data according to some similar behavioral pattern. It's very similar to binning, but the only difference is we do not sort the data according to that particular attribute. Say for example, in binning, if I find a noise in the age value, then the entire database will be sorted according to the age value, and then we will try to form bins. Whereas in clustering, it is not so. We don't take the age value alone. You cluster based on the behavioral pattern of the entire person or the entire data object, and then you try to smooth out those values. and there is always an option of combining human and computer inspection together. Now, when you move, we also saw that data integration is not there in your curriculum. So the next topic we will be looking into is called as data reduction. I'll not be dealing with data integration as of now. So I'll directly move into data reduction. Now, to understand data reduction, why should I reduce data? What is the point in reduction of data? Why should I even reduce data? Imagine I have a large database. I am trying to mine some useful information or knowledge out of that database. And if I have multiple columns, say 150 columns, not all of the columns contribute to the knowledge that we are seeking. Imagine I have the student database. For a student database, I have the name, first name, last name, middle name, initial, father's name, mother's name. All of these are going to be information about the student. So imagine I have the Aadhaar number, the scholarship number, that ID, this ID, everything is there. My objective is to find whether the student will study well or not. Based on his attendance and his previous performance, I need to assess whether the student will perform better in this current semester. So that is my objective. For that objective, should I include the Aadhaar number of the student for analysis? Not required. Is it any way related that the Aadhaar number of the student should be there? Only if the Aadhaar number is there, I can see whether the student learns or not. Is that so? No. So, there are certain attributes or features or columns in that database about a particular object which are not related to the objective that we are trying to seek. In that case, this data might not be required for the mining process. Correct. So, when I give all that data also into the mining process, it takes a very heavy computation to calculate or to excavate the knowledge. And you also might have to spend a lot of more time in furnishing the knowledge. So what happens is, so the easier way of doing it is, all the unwanted data, if you can remove and give only the essence to the data mining algorithm, it is easier to take the knowledge out of that data. So that is our idea behind data reduction. So data reduction is for obtaining a reduced representation of the data set that is much smaller in volume, but yet it produces the same or almost same analytical reduction result. Now, why should we have this database? A database or a warehouse may store terabytes of data, and complex data analysis may take a very long time, as we discussed just now. So, there are three different types of data reduction strategies. The first one is called as dimensionality reduction. The second one is called as numerosity reduction. And the third one is called as data compression. So, we have three forms of reduction strategies for data reduction. The first one is dimensionality reduction. The second one is numerosity reduction. And the third one is data compression. Now, when I look into these, we will see one by one. Then we will understand better. Now, the first methodology is dimensionality reduction. What is dimensionality? In a database, what can I call as dimension? The number of rows across the number of columns is called as dimension of the database. In that case, how do I reduce the dimension? just like in the example that we told earlier, the Aadhaar number of the student is not a dimension that is required for knowing whether the student will perform well or not. Uh, so, such dimensions can be reduced. This dimensionality reduction is very, very essential because it causes a problem called as the curse of dimensionality. When I say curse of dimensionality, it means when the dimensionality of your database increases, the number of rows across the number of columns increases, the data becomes increasingly sparse. You can have a lot of missing values here and there. So that is one problem. So if you get lot of missing values, you cannot get a very good data mining output. So you might have to fill those values. Filling a lot of missing values can be very hectic by itself. And then the density and the distance between points, which is critical to clustering outlier analysis, they become very less meaningful when the data becomes sparse. When we look into clustering, we will understand how we calculate distance between points and how having a sparse data set will reduce the meaningfulness in clustering. Now, every time I try to identify a pattern, I try to do that by doing some permutation combination of the database that is in hand. So if my dimensionality is large, then the permutations and combinations for that particular dimension increases exponentially. So it becomes very, very tough as you add different dimensions to your database. So to avoid the curse of dimensionality problem, we need to go in for dimensionality reduction. So this is done by eliminating irrelevant features, and it also helps us to reduce noise or errors. It reduces the time and the space required for applying the data mining algorithm, and it also allows easier visualization. Now if you can correlate all of these points with the example that we just discussed, it will be easier. Now in the student database and for the Aadhaar number issue, if I eliminate this Aadhaar number or this irrelevant feature, I can reduce the noise in the result of the data mining process. And naturally, I can reduce time also and space required also if I remove the Aadhaar number column for every student. And it also allows easier visualization. Instead of having 150 columns and trying to view all 150, if I can remove some of these which are not contributing to the data mining aspect, it will help in easier understanding or interpretation of the data. There are three common forms of dimensionality reduction. The first one is called as wavelet transforms. The second one is called as principal component analysis. The third one is called as a supervised methodology, which is called as feature selection. We will see little by little on all of this. I'm not going to go deeper into this because in your examination you will be asked only why wavelet is used for dimensionality reduction. You will not be asked to explain wavelet transformation. Wavelet transformation is completely a mathematical aspect. You will not be asked about wavelet transforms. You will just be asked why wavelet transforms are used in dimensionality reduction. Okay, to just understand that concept, I'll show you a example that can help you understand a little bit. Now, the first image shows two sine waves. The second image shows two sine waves plus noise. You forget about the sine waves now. Okay. You think of a temple hundi or a temple hundi. So in a temple hundi, people are coming and putting off their offering inside the hundi. In that case, every 2 minutes somebody is putting some offering inside. and I want to count how many 1 rupees, how many 2 rupees, how many 10 rupees, how many 500 rupees have been put inside. Okay, so the first sine wave, which is green in color, represents the 10 rupee note. So I have seen a 10 rupee note falling at time 2 minutes. After 2 minutes, which means after the hundi is open, 4 minutes after the hundi is open, there is another one. 10 minutes after the hundi is open, there is another 10 rupee note. And 1 hour after the hundi is open, there is another 10 rupee note. So I can plot the occurrence of some event across the time. So the first sine wave represents the occurrence of a particular event over a period of time. Okay. Now if I try to put dots for every time a person drops a 10 rupee note inside the hundi, the data is going to become exhaustive. So I need to note down at 10:30 somebody dropped, at 10:45 somebody dropped, at 12:30 somebody dropped. So this is kind of very hectic. So they calculate the frequency of falling, or from 10 to 10:30 how many 10 rupee notes have fallen inside. From 10:30 to 11 how many notes have fallen inside. I just count the numbers and I put it off into the frequency. So the frequency represents the number of times that particular event has occurred in one span of time. Instead of counting the individual occurrence, I am going to count a bunch which has occurred in some span of time. So the first represents the time space. So along the timeline I note down when all coins have been dropped inside the hundi. And the last image shows the frequency space. It does not, when I look into the frequency space, I do not know at what point that fifth coin was dropped inside the hundi. I only know it's between 10 and 10:30. Do you understand? So, the number of data samples required to represent anything in the time domain is high, whereas the number required for representation in the frequency domain is less. Do you understand the difference? So, every time you have some time-oriented data, it is easier to be represented in the frequency domain. So, for an image also, I can take the wavelet transformation. A wavelet transformation is one transformation that can help you convert a time signal into a frequency signal. Okay, so I can use it upon an image. I can use it on text. So to different aspects, just like how I counted the number of coins on a hundi, I can count anything like that. So when I apply wavelet transform on that data, it becomes the frequency. When it becomes the frequency, it is easier, it requires less space for storage, and it is more effective in representation. So there are two different common wavelet transforms that are used. This first one, which is shown on top, is called as the Haar wavelet, and the second one is called as the Derbyshire wavelet. So this data is superimposed on our existing data to reveal some aspects. So what they do is, I can define a function and I can define some resolution at which I perform the function, and I repeat that function multiple number of times to get the essence out of it. Okay, so these are, you need not understand the mathematical computation of this, but this is just to give you an idea of how wavelets work. Wavelets are easier to work with because they are effective in removal of noise, They work at multiple resolutions. So depending on the resolution that I set, I can either increase the number of frequency parameters or I can decrease the number of parameters. And it is very, very efficient because it works on a complexity of ON. So it doesn't get more than ON. So it's very, very effective in terms of the time it takes for computation. So wavelet is one which is used to reduce the number of dimensions into something less. Then you go in for something called as principal component analysis. PCA is also a dimensionality reduction method, but in PCA, what we do is we project our data on an n-dimensional space. On an n-dimensional space, you project your data and you see what is your objective. The objective is defined by the eigenvector of the matrix. Okay. Now, if I have some data samples and if I want to understand what is the optimum marks the student will receive in the coming semester, in that case, I take all the marks, I put them into a matrix, I calculate the eigenvector of that matrix. That represents the optimal value for that particular objective that I am seeking. For that case, I project that data onto an n-dimensional space and plot the eigenvector on that space. Whatever is very close in proximity to the eigenvector are going to be called as principal components. Instead of trying to pick data samples which are lying so much outside the scope of the eigenvector, if I choose samples that are close to that particular eigenvector, then I can reduce the number of dimensions. Is that understandable? So that is called as principal component analysis. I am giving you just an overview of what is required for these particular methods, because you will not be asked to explain these methods. You will be asked why these methods are used for dimensionality reduction. So this shows the steps for calculating the principal components. The next way of doing this dimensionality reduction is called as attribute subset selection. Just it's very similar to the dimensionality reduction example as we have quoted the Aadhaar number. But this is where I can manually find out, or I can automatically find out the number of duplicates in the data. Or in other words, I can say when the date of birth of the student is given, his age I can calculate from the date of birth. I need not have a separate column for the age. And when the price of the item is given, I can calculate the tax from that price. So there are columns of data which can be derived from another column. In that case, instead of duplicating and storing both the columns, I can select one of that and then use it for data mining instead of using all of the data samples or all of the attributes. When we manually select, it is easier, whereas when we try to select the attributes automatically, we need to follow some heuristics. A heuristic is nothing but a educated guess. So I have some statistical background for understanding the relationship between two attributes, and I can see that if one of the attribute is completely dependent on the value of the other attribute, I can remove the dependent value and only the independent value can be used. We will look into an example for this in the later sessions. The next form of data reduction is called as numerosity reduction. Numerosity reduction is where I try to reduce in number or reduce the volume of the data by choosing smaller forms of representation. Here we have two different methods for reducing the volume. when I just compress it, I can reduce, or I can say, if I have a 100 cross 100 matrix, 100 cross 100 matrix, instead of using 100 cross 100, if I use only 50 cross 50 for further analysis, then my numerosity is reduced. That's how numerosity methods work. It's very simple, but you need to have a statistical background for reducing which numbers you are going to reduce. So for that selection, we are going to use some parametric methods such as regression or log linear models, or you can go in for non-parametric methods such as histogram clustering and sampling. Now, we will be looking into examples for each of these regression and log linear methods. And when I say this, there are three forms of regression. We will look into some examples, but for this session, I'm closing it here. I'll be handling regression models and numerosity reduction in the next session. I thank one and all for joining the session, and I hope you had a good time, and I hope all of you are doing safe and healthy. Stay home, stay safe. Meet you in the next session. Thank you.